everyone. Today we are going to prepare for your test next class. So your first task is to complete the Chapter 9 practice test in sapling. And what this video will do is go over those answers after you complete it, and you can scroll through to the ones that you need. So these video solutions will explain each question just in more detail with some notes from my perspective rather than just reading the feedback in sapling. And then there is a review sheet that has an interval and a test for one sample and two sample proportions. So it's all 4 types of procedures that we have learned so far, and then a couple additional questions in there to help you with putting it all together. Your test next class will have 20 multiple choice and numeric entry questions. So, just like the past couple, a mix of each. And it's 100 formal points because Unit 6 is a big, long unit, and so it will be a big test. In order to study, you should review your homework and warm-ups. From this unit, there's a video going over each warm-up, and your homework has feedback in sapling. We have our notes. You have all the videos from this unit to watch if you want to rewatch them, or the AP daily videos listed under the additional practice on each page are really great. Remember, those are more like direct instruction notes. They're not based on you doing an activity first and then debriefing like our class videos are. They're more of, here's some notes, here's examples that go with it, more of a direct instruction approach, which might be a good way to tie up some loose ends if you're confused about anything. There's personal progress checks in AP Classroom. We suggested that you do A before your quiz, your confidence interval quiz, but B and C are also great practice as well. And then if there are any tutoring sessions with Mr. Crouch, make sure you attend those so that you can get any help that you need that way. All right, so what I'm going to do is if you pause here, then you should be able to complete the Chapter 9 practice test in sapling. There's only 9 questions on it. It's all about tests, significance tests. And then I'll go over those answers. I have a similar video from the Chapter 8 practice test that goes over the intervals, so feel free to rewatch that, which would cover everything on your test for next class. Pause here, complete the practice test, and then unpause to find solutions for the ones that you struggled with. All right, question 1. An opinion poll asks a random sample of adults whether they favor banning ownership of handguns by private citizens. A commentator believes that more than half of all adults favor. So more than half means P would be greater than 0.5. That should be my alternative. So this is very easy. It's not this, not this, not this, not that, and that one is the only one. So because of the equals on the HO, I could have also marked off the last one from the beginning as well, and the second to last one. We need equal for our HO, and then more than is our greater than sign for our HA. Number 2. Lots of words on number 2, so I'm not going to read them out loud to you like I did on the last one. So we're going to read through everything. Okay, select all choices that are not a condition of performing the significance test. Both populations are more than 10 times the corresponding sample size. So that is saying that capital N is greater than 10 times lowercase n. The way that we write that is N is less than 10% capital N. These are the same thing. So that is a criteria that we need to meet. Both populations are normally distributed. No, that is not a condition for proportions. This is what the population distribution of a proportion looks like. You have a bar here and a bar here for yes and no. Can never be normal, it's categorical. Now the sampling distribution can become approximately normal when you have expected counts for successes and failures are large enough to use normal calculations, but the population itself is not going to be normally distributed ever for proportions. The data come from 2 independent samples. We need them to be independent when there's more than one. So that's something that we should have. And both samples were chosen at random. That is definitely a condition that we need. It's one of the most important ones, they say. And that last one was true. So only both populations are normally distributed is not a condition for a significance test for a proportion. Okay, number 3. To determine the reliability of experts who interpret the lie detector tests, a random sample of 280. Okay. The hypotheses are null, suppose suspect is innocent, versus alternative, suspect is guilty. Which of these is a type 2 error? So I like to remind myself here. Type 2 is when you fail to, those go together, reject the null, but it's actually false. So in this case, what that means is I fail to reject the null and I fail to conclude the alternative. And so I think the suspect is innocent, but they're actually guilty. So examiner's decision is innocent, but the suspect is actually guilty. So I know 15 goes on the top. So I can cross out those two. Now, what's the denominator, 280 or 146? And so officially, the type 2 error is going to be, or 140, sorry. Officially, a type 2 error is going to be probability that we fail to reject HO given HA true. That's another way to write it, like a conditional probability statement. And so the suspect's true status is the alternative suspect is guilty. So there's 140 times that happened, and then 15 of those times was the suspect actually being innocent. That one was pretty tricky, but hopefully this explanation helped you out a little bit. Type 2 error is when the alternative is true, but you failed to reject the null. And so if the alternative is true, then the suspect is guilty, but we thought the suspect was innocent. 15 out of 140. Number 4. Okay, so a significance test allows you to reject the null in favor of the alternative at the 5% level. What can you say at the 1% level? So if we reject the null in favor of the alternative at the 5% level, what that means, let's get that out of here. What that means is that our p-value, is less than the alpha level. So in this case, I don't know what my p-value is, but I know that p is less than 0.05 because we rejected the null at the 5% level. Now, if the p is less than 0.05, it could be anything. It could be 0.04, 03, 02, 01, 00, 003, 005. And so I don't know if there's not enough evidence at the 1. You don't know if there is enough evidence at the 1. I actually cannot determine this answer at all. So that's because just because p is less than 0.5 does not automatically make it less than 0.01 as well. So if this were reversed, if this question had said that we rejected it at the 1% level, then I would be able to reject it at the 5% because a number less than 0.01 is always less than 0.05. But that's not always the case in reverse. All right, next question. Oh, I think I skipped one. Oh, well, we'll do this one now. Okay, so, oh yeah, I went out of order. That's okay though. Okay, so on this one, we have a random sample of 100 likely voters in a small city produced 59 voters. Okay, so that gives us a p-hat of 59 out of 100, which is 0.59, Write down everything we know. The observed value was from the test statistic. Okay, great. So z equals p hat minus p over square root p 1 minus p over n. Remember, we use the p. So these two numbers should always be the same. And so that makes it pretty easy to identify because, first of all, the p hat should come first. So it's got to be the 0.59 first. That means I can cross off a few of these. And then p's got to come second, so the other three work. And then we should have the same number here as here, which is not the case there. That's not even close. And then that last one is only one left, and it does meet that criteria. So that's how I do it in my head, or how I do it quickly without doing a lot of calculating. Number 6. Here's what we need to know. We have the probability of a type 1 error, or type 2 error, sorry, is 1 minus the power. Remember, that's called beta. That makes power 1 minus beta. So remember, if I want to increase power, then I should decrease the beta. Now, from there, let's think about how to decrease the beta. We have a whole set of notes on that. And so to decrease the beta, one thing that we could do when the alpha goes up. So remember, they're not complements, but alpha is type 1, and they do describe opposite things. And so increasing the alpha is the best thing to do. Now, it's a pretty tricky idea, but power also increases when you increase your sample size, so not that one, because that's decreasing by going from 50 to 25. Volunteers definitely know. And then two-sided versus one-sided, that is only about the p-value, not the power. So it doesn't have to do with power. All right, number 7. Here we have an interval, and the interval is from 0.26 to 0.35. What conclusion can we draw at the 5% level? So we're using a test and an interval interchangeably. And so what we want to do is see if your HO is inside the interval. In this case, no. So we would reject it. Should make sense, right? 0.25 is not a plausible value. I reject it. So I'm going to reject HO, which means let's cross them and them. And then when we reject our null, we always have convincing evidence. So let's cross U off. And so remember, it goes like this. Reject HO. There is sufficient evidence. And so now I have two options. There is evidence, the true proportion, and we want it to say whatever our alternative says. Oops, so I undid the row. There we go. All right. And I'll put alternative there. Next one. Whew. Alrighty. Here we have p is 0.4, p is not equal to 0.4. We get a z-score of 1.28. What's the p-value? So a couple things. One thing I always make you guys do is draw your normal curve with, so when we do a free response, put 0, and then we have 1.28, would be right about there. You always shade towards the tail, but then you check back with your HA and you see that it's not equal, and you're like, oh, I have to shade the other side too. And so this is what the picture looks like. Then what I do next is use normal CDF, so that's going to be second vars 2. Now the z-score they gave me is positive, so I start with that as my lower. Then I just put a bunch of 9s for infinity, and it's a z-score, so 0 and 1. And that gets me 0.1003. And so that's this area right here. And because I shaded both sides equally, that would also be this area over here. So remember, my p-value will be 2 times 0.1003. So I can just hit times 2 on my calculator after I get it, and that is my p-value. So 0.2005. There. And notice how they put 0.1 as a choice. So you got to be very careful in a problem like this. All right, here is the last one. We have type 1 error. What would that mean in context? So what I like to do again is just first I define what's a type 1 error. That is rejecting the null when it's true. Okay, so I'm going to reject the null and conclude the alternative. I think that mu is less than 14, but I'm wrong. The null was actually true. And so in this case, I reject that mu equals 14, and I conclude there is evidence that the mean weight is less than advertised, so they're being underfilled, and I'm wrong. So the bags are, this means concluding that the bags are being underfilled when they really aren't. And so that is a type 1 error. Reject the null. You think the alternative is true, but it's really not. All right, make sure you do the rest of the study materials by completing the FRQs and checking your answers, and then attending any tutoring sessions that you need. Watch all the videos you need in AP Classroom, the AP Daily videos, rewatch these videos, whatever helps to prepare for your test next class. Thank you so much. Have a great day.